Okay, so we have an example here to determine the dead loads acting on beam CD and girder AE. So let's start labeling. This is point A, this is point B, this is point C, point D, point E, and point F. So we want to determine the dead loads acting on beam CD, which is here, and girder AE, which is here. So we can get started by labeling some areas and additional information that we need. Um, we know that this floor beam, I'm going to call this the area of the floor beam, is equal to 18.3 inches squared. And we also know that the area of the girders, okay, I'm going to call this AG. G. This area is 32.7 inches squared. And we also know that, I'm just going to draw this squiggly line here, that this is 4 inches thick concrete on top of this floor. So before we get started into actually determining the dead loads, let's determine how heavy the self-weight is of these beams and concrete. So I'm going to say the unit weight of the concrete, I'm going to call it unit weight of the reinforced concrete, is equal to, from my text, 150 pounds per feet cubed times, I'm going to do this per 12-foot section. So it's going to be times 4 inches thick concrete, and we have to convert that to feet. So it's going to be 1 foot per 12 inches. And then we have to multiply that by the 12 feet here. So times 12 feet. And then we can start canceling some units out. Cancels, this cancels. These turns into squares, so it becomes 1. So that means that the unit weight of the reinforced concrete above this floor, or on this floor, is equal to 600 pounds per foot per 12-foot section. So that's per 12-foot section here. Okie dokie. Moving on, we're going to do the unit weight of the floor beam. So we're going to use AFB here. I'm going to call this WFB, which from my text is 490 pounds per foot cubed times 18.3 inches squared times, now we can't just do 1 over 12, we have to square that as well. So you could write 1 over 12 squared, or you can write 1 foot squared is over 144 inches squared. Okay, so let's cancel our units back again here. Inches squared, feet squared becomes 1. So the weight of our floor beam, or the weight of, well, every floor beam in this problem, is equal to 62.3 pounds per foot. Okay, so now we have 2 self weights. We got to do one more for the girder. I'm going to move this over, and I'm going to do a little line here. So this is going to be the weight of the girder, which is, from my text, 490 pounds per foot cubed times the area of the girder, 32.7 inches squared, times, again, we have to do the same conversion, foot squared over 144 inches squared. Again, canceling. We're going to be left with the weight of the self-weight of the girder is equal to 111.3 pounds per foot. Okay, so now we have our self weights. Now we can go into actually solving the dead load problem. So let's start with floor beam CD, because if we're looking at this from a top-down perspective or plan view. If we were to take a look at the cross view, the cross section of this, it would kind of look something like the the concrete is up here, the floor beam is here, and the girder is here, and the columns are here. So the concrete is above everything. The floor beam is under it. The girder is under it, and then you have the columns under that as well. So the load transfer is follows that pattern. So we're going to analyze the floor beam first. So let's do exactly that. So I'm going to do floor beam C to D. So let's look at the beam. If we were to draw a line here, so this is point C, this is point D. This is going to be a distributed load across the beam. So I'm gonna go ahead and draw my arrows, and we need to know what the tributary area is of this distributed load. So what we're going to do is just some simple multiplication. So this is I'm going to draw the frame down here again, just to simplify some things instead of drawing over myself over and over again. So we've got point A, B, and then E, F, C, D. This is the girder, or the floor beam going across. We know that the tributary area is going to be halfway. It's going to be from here to here, because this floor beam or this girder will take this part. I'm gonna hatch it instead. This floor beam will take this area. This floor beam will take this area, or they're girders. This is a girder, this is a girder, but this floor beam here will take this area because it's halfway on either side. So this would be 6 and 6, therefore making this 12. And we know that the distance here is 25 feet. So 12 times 25 is 600 foot. This is feet squared. I'm just going to erase this to keep some room for me. So we now know that this distributed load from the concrete is 600, but we also have to take into account the weight of the actual floor beam. So it's 600 plus the 62.3, which means that this total distributed load is 662.3 pounds per foot. Okay, and we're going to have some reactions here. We know that this distance across is 25 feet. So if we were, basically what we have to do is multiply 662.3 by 25 and then divide that by 2, because there's only 2 reactions. So Cy is equal to 8,278.4 pounds. And that also has to equal dy because there's only 2 reactions. So these are the reactions for the floor beam, the dead loads for the floor beam. So let's move on to girder AE now. I'm gonna do a little squiggly line there. So this is the girder from A to E. So same thing. Let's draw a line here. That line being the beam from A to E. So that line is, I'm going to zoom in here. That line is this line right here. Okay. Again, there's a distributed load over this whole thing from the concrete and from the floor beam, rather. The concrete is going to be factored into this So we don't do like 600 again, because that 600 is going to be incorporated in our analysis here. So we have the distributed load, which this distributed load, again, as I said before, is not the same as the concrete. It is now the self-weight. So this self-weight, I'm going to write this down here because I know what it's going to look like, is going to be 111.3 pounds per foot. And then we're going to have, like I said before, with the transfer of power, or the transfer of weight from the floor beams to the girders, from the concrete to the floor beams to the girders. So we have the floor beam here. What now we're going to do is transfer these reactions down to the girder. But if we were to look at our system, like we're looking at it now on a cross-sectional view. So point CD, we are only seeing, because we're looking at beam AE, we don't care about what's happening over here. We care about what's happening over here. So we're only going to take into account one reaction, one side of the reaction. So this one. So that's where our reaction is going to be here. This reaction is going to be 8278.4 pounds. But okay, cool. We have one force coming down from the middle of from point C. But what's going on here? What's going on here? So we need to know, well, what is the tributary area of, what are the forces acting on point AB and EF? And spoiler alert, they're going to be the same because they're going to have the same tributary areas. So let's take a little quick pit stop and let's do floor beam AB. You could do either AB or EF. Like I said, they're going to be the same. Okay, so this is going to be floor beam A to B. So this is point A, this is point B, or yeah, A to B. This is the distributed load going across again. And it's not going to be 600 because, like I drew before on the tributary area diagram, it's half of 600 because it's got half of the tributary area. So it's only going to be 6 times 25, so 300, plus the self weight of the floor beam here. I keep waving my Apple Pencil like you can see me, but you can't, so I have to remember I have to draw it. So it's plus the 62.3. So it's, this self weight is 362.3 pounds per foot. Okay. And again, well, the distance here is still the same. This is still 25 feet, but the reactions here, they're not going to be half of the reactions here, because like this is not half of this. Okay, so AY is equal to 4,528.75 pounds, which is equal to the reaction at B. So now we know what numbers to put here, because like I said before, the floor beam AB is the same as the floor beam at F. What is it? EF. I keep calling it floor beam. I know I'm wrong when I say that. I know in the problem it's they're girders. Okay. So moving right along, we know that this is 4528.75 pounds, and this side is 4528.75 pounds. So again, add these three numbers and then multiply this by, this is going to be 12 plus 12, so this is 24 feet from here to here. So again, let's do it off to the side. 111.3 pounds per foot times 24, oops, 24, what the heck was that, feet, plus 8278.4 pounds plus 2 times 4528.75 pounds. Okay, so you're going to get an answer that's in pounds, and then you have to divide that by 2. So basically, you're just taking all of this, divide it by 2, and you'll get your answer for AY and EY. So AY equals, AY is equal to 10,003.6 pounds, and which will be the same as EY. This is EY. This looks horrible. Let me fix that. And that is our answer for the dead loads to the girder. So this is all. So these are the answers here. To this is the answer, and this is the answer to part A. Whew. Okay, now part B. If we're gonna, now we take a 6-inch thick brick wall that's 7 feet high and 25 feet long, and put it directly over the floor beam CD. Determine the dead loads now again on CD and AE. So let's run through that. Okay, so that was part A. Now we're moving on to part B. I'm gonna move this out of the way. Shoop. Okay. So move that out of the way, and let's draw a squiggly line here. All right, moving on. So this is how I did this problem. I took this as like we're gonna again find the self weight of the brick wall. Everything else stays the same. The self weights of the beams, concrete, girders, whatever, all stays the same. Now we're just gonna find the weight of the brick wall. So I said the 6-inch thick. I just converted that real quick to half a foot times 7 feet times 25 feet gives us the volume of the brick wall, which is 87.5 feet cubed. And then from my text, I have 10 pounds per foot squared per inch. I know, really weird, but it was 10 pounds per foot squared per inch times 12 inches per foot. Again, running through the conversion real quick, you get that for the brick, the unit weight is 120 pounds per foot cubed. And we have a cubic foot here. We know that this is per cubic feet, so let's go ahead and multiply those. So we're going to get the weight of the brick wall equals 120 pounds per foot cubed times 87.5 foot cubed. Let's go ahead and cancel those out. So we'll get that the weight of the brick wall equals 10,500 pounds. So we're basically just going to run through this whole problem again, but now we're adding this weight, which should be relatively simple. I mean, I'm just going to go ahead and do it real quick. This is floor beam CD. Again, distributed load here. Again, same 662.3 pounds per foot, but now we have the 10,500 pound brick wall right in the middle. I placed it right at the middle. You could probably add it some way and add it to the distributed load somehow. I didn't feel like doing that. So CY is equal to, and again, we know that this is 25 feet. So you take this 662.3, multiply it by 25, add 10,500, divide by 2, and you're going to get your reaction answers, which are 13,529 pounds, which is the same at dy as well. So that's your answer here. And I'm not going to do floor beam AB again because nothing changes. So we're going to stick with this answer and incorporate that into our girder for AE. So we have A, E, and again, I'm going to draw this in as point C. I should have labeled that earlier on the previous part of the problem, but okay, again, distributed load here. Let's go ahead and keep drawing a bunch of arrows. Okay, you have a distributed load. You have the reactions from the floor beams. And you have, so we again know that the self-weight here is 111.3 pounds per foot. You have the reaction from AB, which we already knew as 4,528.75 pounds. And then you have this new reaction that we found, so 13,529 pounds. And then you have the same number over here, 4,528.75 pounds. So, and we know that this is 24 feet on from A to E. Let's fix that. So, AY, you run through that whole, process again, you'll get that AY equals 12,629 pounds. That looks horrible. Pounds, which is the same at EY. So that's your answer. Again, that's the answer to part B of the problem. I hope you enjoyed.